Let's jump right into this explainer. Today, we're decoding the DNA of a true technological behemoth. For years, you probably just knew them as the company making graphics cards for tricked-out gaming PCs. But today, they are the absolute, undeniable engine of the artificial intelligence boom. I'm talking, of course, about NVIDIA. $3.35 trillion. That was NVIDIA's market capitalization back on June 18, 2024. It's a historic milestone that officially crowned them the most valuable company in the world. But look, you do not reach a $3 trillion valuation by accident. It requires a visionary leap of faith and building an almost impenetrable technological moat. So, how exactly did they pull it off? Here is our roadmap for today. We'll cover 1. The trillion-dollar AI awakening, 2. From gaming to deep learning, 3. The ultimate software moat, 4. The competitive landscape, and finally, 5. The future of AI domination.
All right, part 1, the trillion-dollar AI awakening. To really grasp NVIDIA's massive success, we actually have to look backward at the exact problem that kept artificial intelligence stuck in the mud for decades. It's known as the AI winter. Throughout the 1970s and 80s, AI research just deeply stagnated. Scientists had these brilliant theoretical models, but they hit a wall. A severe lack of funding, combined with prohibitively high computational costs, essentially froze the whole industry. I mean, every single step forward was a massive financial drain. They were quite literally sitting around waiting for a hardware miracle.
Moving on to part 2, from gaming to deep learning. This is where it gets fascinating. A technology built specifically to make video games look pretty became the ultimate Trojan horse for modern AI. In 1999, NVIDIA invented the GPU, the graphics processing unit. It was designed to render complex 3D pixels for gamers. But the real, absolute game changer came in 2006 with the launch of CUDA. This was a software layer that let developers use these GPUs for general-purpose computing. Suddenly, GPUs weren't just pushing graphics. They were parallel processing powerhouses. Fast forward to 2012, and researchers used NVIDIA hardware to power the AlexNet algorithm, crushing a massive image recognition competition and leaving traditional processors in the dust. By 2016, NVIDIA was the brain behind Google DeepMind's AlphaGo, which famously defeated the world champion in the insanely complex board game Go. They transformed from pixel pushers to the architects of world-beating intelligence. And this rapid evolution perfectly set the stage for large language models, or LLMs. Think about OpenAI's ChatGPT. These are foundation models trained on oceans of unlabeled data. Their insatiable hunger for crunching billions of parameters simultaneously was the exact problem NVIDIA's parallel processing GPUs were born to solve. It was a match made in tech heaven. You can literally see this pivot playing out in the numbers. Over a projected 5-year period, data centers boast a staggering 51% compound annual growth rate. That entirely eclipses their traditional gaming and automotive sectors, which are sitting back around 10%. Data centers are no longer a side hustle. They are the fundamental backbone of the global AI infrastructure and the undisputed engine driving NVIDIA's massive growth. Let's dive into part 3, the ultimate software moat. So here is the secret sauce. NVIDIA's true power isn't actually just in the silicon hardware. It is an inescapable software ecosystem. We're talking tools spanning across wildly diverse industries. AI Enterprise for seamless cloud implementation, NeMo for speech and natural language processing, Clara for revolutionizing medical imaging and genomics, and the Triton Inference Server for complex model deployment. Once a developer starts building on this highly optimized platform, leaving for a competitor becomes a massive headache. It's a remarkably sticky, brilliant ecosystem. But let's be real. Maintaining this sticky ecosystem is not cheap. It requires massive, capital-intensive operations. Even back in 2020, NVIDIA employed nearly 14,000 people globally, driving standardized, massive-scale innovation. Building the future at this level requires continuous research and just immense upfront investments in both physical and digital infrastructure. This is heavyweight operation, through and through. Yet despite being this walled-off giant in some ways, they fully embraced open innovation in others. A prime example is co-founding the Alliance for OpenUSD alongside creative heavyweights like Pixar, Adobe, and Apple. Their goal? To literally standardize the 3D internet and the metaverse. They don't just want to build the products, they are actively setting the foundational rules for the digital world, ensuring their hardware remains right at the very center of it all. Which brings us to part 4, the competitive landscape. Let's look at the actual battlefield when stacked directly against AMD's Radeon RX 7900 XTX. AMD is a seriously fierce competitor. They offer a highly compelling price point around $1,000 and great power efficiency. But NVIDIA? They maintain a premium grip on absolute top-tier performance, especially in computationally heavy areas like ray tracing, where they comfortably push over 90 frames per second. They can command that $1,700 price tag because, at the very bleeding edge, they still wear the crown. But as we touched on earlier, the real turf war isn't just in the physical chips. It is in the code. The ongoing battle for developer loyalty pits AMD's ROCm against NVIDIA's CUDA. AMD is pushing incredibly hard to expand its influence, offering ROCm as a competitive, cost-effective software alternative, but NVIDIA's CUDA has a multi-year head start and incredibly deep industry integration. Breaking that iron grip on developer habits, that is AMD's ultimate hurdle. And then we have the fascinating frenemy dynamic with Microsoft. This is where the stakes hit the stratosphere. Microsoft isn't just a casual partner. Right now, they are actively orchestrating a massive $100 billion bet behind their own AI empire. You might have heard rumors about their massive Stargate supercomputer project. Now, on one hand, NVIDIA partners closely with Microsoft to integrate their powerful GPUs directly into the Azure cloud. But on the other hand, that staggering $100 billion Microsoft war chest is heavily funding software like Azure Machine Learning that aims to bypass underlying hardware entirely, directly competing with NVIDIA's CUDA. Add in Microsoft heavily pushing its own metaverse tools like Azure Digital Twins, and you've got this high-wire balancing act of deep, vital collaboration paired with direct billion-dollar competition. Finally, Part 5. The future of AI domination. Looking ahead, a major catalyst for their future is B2G, business to government. Through initiatives like the US Brain Initiative from 2013 and the EU's Coordinated AI Plan in 2018, governments globally are pouring vast funds into AI for healthcare, research, and national infrastructure. Securing these massive global partnerships is absolutely critical. NVIDIA isn't just selling server racks to tech startups anymore. They are providing the computational backbone for entire nations. And they definitely aren't resting on their laurels. The NVIDIA Drive Hyperion 8 platform is a perfect example of them expanding the empire into autonomous vehicles. By jumping headfirst into the incredibly complex, high-risk world of self-driving cars back in 2020, NVIDIA proved they are constantly hunting for the next massive wave of compute demand. They are proactive, never reactive, always modeling the competitive landscape to stay 2 steps ahead. Which leaves us with one final, absolutely crucial question. With expected market consolidation, looming legal battles over training data, and strict new AI legislation on the horizon, can any competitor truly breach NVIDIA's walls? They've built a staggering hardware advantage, a deeply entrenched software moat, and a culture of relentless innovation. But as history shows us, no tech empire goes unchallenged forever. Thank you so much for joining me for this explainer. Keep learning, keep questioning, and I'll see you next time.